Yes, flexible metal conduit, or FMC, can be used for short runs from the main electrical panel to an electrical component if the distance is less than 24 inches, but it is important to understand applicable code requirements, benefits and limitations. According to National Electrical Code, Section 350.30b, FMC may be used where it is necessary to employ flexibility. However, Section 350.30 code specifies that FMC shall not be used in concealed locations. This means it cannot be installed inside walls, ceilings, or under floors. Section 350.30c2 states that FMC shall not be used in wet locations, which means it's not suitable for areas where it may be exposed to moisture. Additionally, Section 350.30c3 says that FMC shall not be used where exposed to severe physical damage, as it can be easily damaged by sharp objects or heavy equipment. The benefits of using flexible conduit are many. Firstly, flexibility allows for easier installation in tight spaces or around obstacles. Secondly, it reduces labor time because it eliminates the need for bending rigid conduit. Thirdly, cost savings, as flexible conduit is typically less expensive than rigid conduit. Remember, it is not for concealed locations and cannot be installed inside walls, ceilings, or under floors. Not for wet locations, so it is not suitable for areas where it may be exposed to moisture, and it is subject to physical damage. I would recommend that you use liquid-tight flexible metal conduit, or LFMC, for runs that may be exposed to moisture. Always secure the conduit properly to the electrical components and panel to prevent strain or damage. Protect the conduit from physical damage if necessary, and always follow applicable electrical codes and regulations. Some additional points to consider when using flexible conduit include proper sizing and support. The size of the conduit should be appropriate for the number and size of conductors being installed, as per National Electrical Code tables. The conduit must be supported at intervals specified by the code, typically every 4.5 feet and within 12 inches of boxes or fittings. Proper grounding is also crucial when using flexible conduit. A separate grounding conductor must be installed within the conduit to ensure a safe and effective ground path. The grounding conductor should be sized according to National Electrical Code Table 250.122, based on the rating of the overcurrent protection device in the circuit. When making connections to boxes or fittings, use appropriate connectors that are listed for use with flexible conduit. These connectors provide a secure and reliable connection, and they also help to protect the conductors from abrasion or damage. When pulling conductors through the conduit, use a pulling lubricant to reduce friction and make the job easier. Avoid overfilling the conduit with conductors, as this can make it difficult to pull the conductors and can also damage the insulation. Always inspect the conduit and connectors for any signs of damage before installation. Replace any damaged components to ensure a safe and reliable installation. When working with electrical systems, always follow safe work practices, including wearing appropriate personal protective equipment such as safety glasses and gloves. De-energize the circuit before working on it, and use a voltage tester to verify that the circuit is de-energized. If you are not comfortable working with electrical systems, hire a qualified electrician to do the job. They have the knowledge, skills, and experience to perform the work safely and correctly. The National Electrical Code, or NEC, provides detailed requirements for the installation of electrical systems, including flexible conduit. Always refer to the latest edition of the NEC for the most up-to-date information and requirements. In addition to the NEC, local codes and regulations may also apply. Check with your local authority having jurisdiction, or OJ, to determine if there are any additional requirements that must be followed. Proper planning is essential for a successful electrical installation. Before starting the work, develop a detailed plan that includes the location of the conduit, the size and type of conductors, and the method of support. This will help to ensure that the installation is done correctly and safely. When installing flexible conduit in a commercial or industrial setting, consider the potential for exposure to chemicals, moisture, or physical damage. Choose a conduit type that is suitable for the environment, such as liquid-tight flexible metal conduit, or LFMC, for wet locations, or rigid metal conduit, or RMC for areas where physical damage is a concern. Always use the correct tools for the job. Using the wrong tools can damage the conduit, connectors, or conductors, and can also create a safety hazard. Some common tools used for installing flexible conduit include a conduit bender, a conduit cutter, a wire stripper, and a screwdriver. When making bends in flexible conduit, use a conduit bender to avoid kinking or damaging the conduit. Make smooth, gradual bends to minimize stress on the conduit and conductors. Avoid making sharp bends, as this can damage the insulation of the conductors and reduce the ampacity of the circuit. When cutting flexible conduit, use a conduit cutter to make a clean, square cut. This will help to ensure a good connection with the connectors. Deburr the cut end of the conduit to remove any sharp edges that could damage the conductors. When stripping the insulation from the conductors, use a wire stripper to avoid nicking or cutting the conductors. This can weaken the conductors and create a potential for electrical shock. Make sure to strip the correct amount of insulation to ensure a good connection with the terminals or connectors. When making connections to terminals or connectors, tighten the screws or nuts securely to ensure a good electrical connection. Loose connections can cause overheating, voltage drop, and even electrical fires. Use a torque wrench to tighten the connections to the specified torque value. After completing the installation, test the circuit to verify that it is working properly. Use a multimeter to check the voltage, current, and resistance of the circuit. Look for any signs of problems such as overheating, voltage drop, or excessive current draw. If you find any problems, troubleshoot the circuit to identify and correct the cause. Keep a record of the electrical installation, including the location of the conduit, the size and type of conductors, and the date of installation. This information can be helpful for future maintenance or repairs. Regularly inspect the electrical installation for any signs of damage or wear. Replace any damaged components promptly to prevent electrical hazards. Follow a regular maintenance schedule to ensure that the electrical system is operating safely and efficiently. The National Electrical Manufacturers Association, or NEMA, publishes standards for electrical enclosures and other electrical equipment. These standards provide guidance on the design, construction, and testing of electrical equipment. Consider the environmental conditions when selecting electrical enclosures. Enclosures are available in a variety of materials and designs to protect electrical equipment from moisture, dust, corrosion, and other environmental factors. Choose an enclosure that is suitable for the specific application. Provide adequate ventilation for electrical enclosures to prevent overheating. Overheating can damage electrical equipment and reduce its lifespan. Install ventilation fans or louvers to provide adequate airflow. Protect electrical enclosures from physical damage. Enclosures can be damaged by impacts, vibrations, and other physical forces. Install barriers or guards to protect enclosures from damage. Follow the manufacturer's instructions for installing and maintaining electrical enclosures. The manufacturer's instructions provide detailed information on the proper installation and maintenance of the enclosure. Use only listed or certified electrical equipment. Listed or certified equipment has been tested and approved by a recognized testing laboratory such as Underwriters Laboratories, or UL. This helps to ensure that the equipment is safe and reliable. Use appropriate wiring methods for the application. The National Electrical Code specifies the allowable wiring methods for various applications. Choose a wiring method that is suitable for the environment and the type of electrical equipment being installed. Provide adequate overcurrent protection for electrical circuits. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from damage caused by excessive current flow. Size the overcurrent protection devices according to the National Electrical Code. Ground electrical equipment properly. Grounding provides a safe path for fault current to flow back to the source, which helps to protect people from electrical shock. Follow the National Electrical Code requirements for grounding electrical equipment. Use appropriate personal protective equipment, or PPE, when working with electrical equipment. PPE includes safety glasses, gloves, and other equipment that protects workers from electrical hazards. To energize electrical circuits before working on them. De-energizing electrical circuits eliminates the risk of electrical shock. Use a voltage tester to verify that the circuit is de-energized before working on it. Follow lockout/tagout procedures when de-energizing electrical circuits. Lockout/tagout procedures prevent electrical circuits from being accidentally energized while workers are performing maintenance or repairs. Use caution when working near energized electrical equipment. Maintain a safe distance from energized electrical equipment to avoid electrical shock. Be aware of the potential for arc flash when working near energized electrical equipment. Arc flash is a dangerous electrical explosion that can cause serious injuries or death. Wear appropriate arc flash PPE when working near energized electrical equipment. Follow safe work practices when working with electrical equipment. Safe work practices help to prevent electrical accidents and injuries. The National Electrical Code, or NEC, is a comprehensive set of standards for the safe installation of electrical systems. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The National Fire Protection Association, or NFPA, publishes the NEC. The NFPA is a non-profit organization that develops and publishes codes and standards for fire safety. State and local governments adopt the NEC into law. Check with your local authority having jurisdiction, or OJ, to determine which edition of the NEC is in effect in your area. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is divided into chapters, articles, and sections. Each section of the NEC contains specific requirements for electrical installations. The NEC is a complex document, but it is essential for anyone who works with electrical systems. Understanding the NEC can help to ensure that electrical installations are safe and compliant with code. There are many resources available to help you learn about the NEC. The NFPA offers training courses and publications on the NEC. There are also many online resources available, such as websites and forums. Consider attending a training course or reading a book about the NEC to learn more about electrical safety. Always consult with a qualified electrician if you have any questions about electrical installations. A qualified electrician can help you to ensure that your electrical system is safe and compliant with code. Electrical safety is everyone's responsibility. By following safe work practices and understanding the NEC, you can help to prevent electrical accidents and injuries. Remember to always prioritize safety when working with electrical systems.